So one of the big problems facing home automation today is the wide variety of low power standards we have for all the different devices to communicate with each other. Now we have standards like Zigbee, which is adopted by some people. We have proprietary standards like Z-Wave, and then we have device manufacturers that go off and make their own radio standard, possibly based on something that exists. But then you gotta buy all their different hubs and connect all of their hubs to build out your home automation system. And this is a huge pain. And as IT technology people, we've already developed a solution to internetworking between multiple disparate networks. That's called the Internet Protocol, IP. So why can't we bring that internetworkability of the IP Internet Protocol into home automation? And that's exactly what Matter does. So based on IPv6, Matter is intended to bridge all of the different home automation devices, whether they're using Ethernet, Wi-Fi, or a low power standard such as Thread, and have them all directly speak IPv6 so they can all communicate with each other. So today I'm going to explore the design of the Matter protocol, the corresponding Thread radio protocol, and some of the other interactions involved in this new unified home automation standard. So if that's interesting to you, then come along on this adventure. But first, I'd like to thank SmartWave Shades for sponsoring this video. They kindly provided these nice, beautiful roller shades for me to demonstrate in this video because these guys support the brand new Matter and Thread protocol standard, so they make a great example. I've also had motorized roller blinds in my room here for quite a long time. It really helps when I'm recording or doing other work. I can open and close them directly from my Stream Deck, which is super nice. So more about them later in the video. So basically, since the invention of the electric light, some people have been trying to do electronic automation of their house. There were some really early systems that use like low voltage relay contacts to turn lights on and off. So then you could have like a big control panel next to your bed to turn on and off all the lights in your house. And that was kind of a wiring nightmare. So we invented protocols, how devices can speak to each other in a language they can understand. One of the earliest protocols I can find for smart homes is the X10 protocol, which actually turns 50 this year. Yeah, it's from 1975. And using the X10 protocol and very old DOS-based computers, some people attempted to automate their house. Here I have a picture of a PC Junior that I found. This is from 1991, I believe. That same guy actually built motorized blinds for his house too, but he had to build them on his own and wire them and program them and all that kind of stuff. And this was the days before microcontrollers too. So progressing a bit through technology, we decided that the future is wireless, and two new home automation protocols came out late 90s, early 2000s. So Z-Wave came out in 1999. It was designed for lighting primarily, but could do other things as well. And Zigbee came out a few years later. It's based on IEEE 802.15.4, which came out in 2003. So in both of these standards, we have devices which are probably battery powered. They can't talk very much because they have a battery. And so we have higher level devices like controllers and routers that help relay messages across the network. So we have a nice stable mesh. Now in both of these network designs, we have a tree. So at the top of the tree, we have some controller which is all-knowing, knows all the other devices. And below that, we have levels of devices which are less and less functional. So at the bottom of the tree, we have end devices that are battery powered. They can only send and receive messages for themselves. We might have routers in the middle that can relay messages on behalf of other nodes. But ultimately, everything ends up at the top of the tree, at the controller. And neither of these protocols were designed to operate beyond the scope of their single tree. So when we bring in software like Home Assistant, Apple Home, Google Home, Alexa, things like that, they need to be able to talk to possibly multiple different networks. If you have a network of Z-Wave light switches, for example, like I do, you might want to talk to the Z-Wave network and also the Zigbee network from the same controller like Home Assistant. But Z-Wave and Zigbee weren't designed for their messages to be transferred off network. So every time we go off network, we have to have the controller do some translation. It's involved in decrypting the messages from the device, translating them to some other format that something else can accept. Maybe that's MQTT, maybe that's going to some cloud service, whatever. The controller has to do this protocol translation. And this is how you get vendor-specific hubs. So maybe your Philips Hue lights can talk Zigbee natively, but you want to talk to them from Home Assistant that doesn't speak Zigbee. So you need to get a Philips Hue controller, but then there's no standard for how we should translate Zigbee messages into Ethernet messages. So Philips Hue does their own thing, Zigbee to MQTT does their own thing, Z-Wave Home Automation and Home Assistant does their own thing again. and there's no standard for this. So that's where Matter comes in. Matter was built under the assumption that all devices in the home automation network can talk directly to each other over IPv6. Now that doesn't mean that they're going to talk directly using the same underlying link layer protocol. IPv6 can be routed, so we can send a packet between nodes and have it route across a complicated network. So with Matter, we're not customizing any of these packets to be specific to, say, Ethernet or Wi-Fi or Thread. So with Matter, we create a thing called a fabric, and the fabric has an ID and it has encryption keys and things like that. And across the fabric, any device can take any route it chooses to get to any other device or the controller. So our fabric might span Wi-Fi, it could span multiple Wi-Fi networks, it could span multiple Thread networks. Whatever our underlying transport is, we can have more than one of them and Matter doesn't care. So now, because all of our communications are direct from the controller all the way through the different physical layers to the device, we can also bring in end-to-end encryption. So now we're not relying on the Zigbee or Z-Wave gateway to decrypt and re-encrypt traffic, or possibly not even encrypt at all over Wi-Fi or Ethernet. Now all of our traffic is end-to-end authenticated and encrypted, and the routers across the way can't modify our package. So we don't have to rely on trusting, say, an Apple TV, which might be a Thread border router. It's processing encrypted Thread packets, and it's not doing any decryption. And finally, Matter relies on another very popular protocol called mDNS, multicast DNS, and DNS service discovery, and that's how it's able to find the destination addresses of devices. So mDNS is already really widely used to discover network devices that are on the same network. We bring that to Matter as well. So now let me get my blinds installed so we can see what Matter traffic looks like. So the installation process here went pretty simple. I measured and marked where I was going to put the brackets. The instructions told me where to put them. Drilled in the brackets into the window frame. Not hard at all. For blinds this size, they just have 2 clip-on brackets. For bigger blinds, they might have more. So I'm checking to see how well it fits. I measured it according to their instructions and was really hoping it would fit well, and it fit perfectly. So their instructions were excellent. I really debated here about taking apart the trim on the window and reinstalling the trim to hide wires, because I really hate using battery power when I have to change or recharge the batteries all the time. But SmartWave has these solar panels. They stick on the window behind the blind motor so you can't see them from the inside, and they keep the blind charged. So I'm trying those out. Just same thing on the other window, the brackets, install the blind, etc. I also plugged them into power just for their first charge, and then I can get out of pairing them. So now that I got my blinds set up, I've got to join them to my network. Give them the Wi-Fi password. Except these blinds don't speak Wi-Fi, they speak Thread. So what's Thread? So backing up a bit, Matter assumes that we can communicate between all of our devices using IPv6. And that's great if we're using a transport protocol like Ethernet or Wi-Fi, which support IPv6 natively. But one of the big advantages of some of these home automation protocols is how little power they use. It's really important for battery-powered devices, like my blinds here, to not have to use a whole bunch of their battery power listening for Wi-Fi frames. So we need a wireless transport protocol that can carry IPv6 packets, but uses a lot less power for the devices than Wi-Fi. And actually, the Wi-Fi Alliance has something we could use for this. It's called 802.11ah, or Halo. So it's 900 megahertz Wi-Fi. It runs at 1/10 the speed of normal Wi-Fi, 1/10 the bandwidth. And this is primarily designed to give long range, though, and not really better battery life. Now, if you had a full Halo network, you could run Matter over that, and Matter would be just fine. But instead, we looked at another protocol that already existed, and that's called 6LoWPAN. So 6LoWPAN was named by engineers, that's why it doesn't have a fancy name, and it was designed specifically to carry IPv6 traffic on top of IEEE 802.15.4 personal area networks. That's the same underlay transport that's used by Zigbee. And when 6LoWPAN was developed, it was designed for meshes of sensors in sort of the wilderness or areas without good internet service. So one example I found of this was reading smart meters. So every smart reader could speak 6LoWPAN to each other. They'd form a mesh where they all talk to all of the other smart meters that are close by, and they can help relay their IPv6 packets to the internet. So as long as someone has IPv6 internet connectivity, all of them then essentially have internet connectivity, and they can get their data back to the cloud. And I found some similar applications like remote monitoring, remote sensors, remote IoT stuff. And that's really where 6LoWPAN was developed. So in order to fit an IPv6 header and a UDP header inside of an 802.15.4 frame, which is not that big, they use a technique called header compression, where essentially we can shrink down some of the fields if we know they're all zeros, or we can fill in addresses like the MAC address so we don't have to transmit that in the IP address. And 6LoWPAN also has a full system of fragmentation, so you can send full-size internet packets across this low bandwidth link. So 6LoWPAN was chosen as the basis of Thread. In a 6LoWPAN mesh, all of the devices get assigned IPv6 addresses within the scope of the mesh. They can speak to each other, they can discover their routes, they can figure out the most efficient path to route between any other node in the mesh. And unlike Zigbee or Z-Wave, this is a true mesh. Any node can talk to any other node. It's not forming a tree back to some higher level controller. Any of the routers are capable of being that control function. And since this is a full routed setup as well, that means we can have more than one node bridge connectivity between our Thread network and the rest of the world. So for example, I could have 3 separate Thread border routers placed around my house just like Wi-Fi access points, and my Thread devices will talk to the one closest to them when they need to exchange packets with the internet. And likewise, devices on my global network, my Wi-Fi, my wired Ethernet network, can also send packets to the Thread border routers and they'll get routed across the mesh appropriately. So now that we understand the purpose of the Thread network, I've set up my own Thread network using a Raspberry Pi and a Nordic Semi USB dongle. So now we can get these blinds paired to my new Thread network. So to start the pairing process, I got to push the button 3 times. That puts the device in pairing mode. From then, I can go to the Home Assistant app and click Add a Matter device and scan the QR code. So every Matter device has a QR code on it with provisioning information. And from there, it's up to Home Assistant to do all the pairing from the app. So I just wait a long time, and then I can add it to Home Assistant and give it a name. And it's really that simple. So if you've done home automation for a while, you probably noticed that I used the Home Assistant app to pair that device to a Thread network without exchanging any sort of passwords or using a SmartWave specific app. And that's possible thanks to one of the last tricks of Matter, Bluetooth provisioning. So when you go out and you buy a new device, you've got to connect it to your Wi-Fi network, to your Thread network. You got to give it the password. And we can't start speaking IPv6 until we've exchanged that password to get it onto the network. So the way that a lot of vendors have done this up until this point is you have to download an app specific to whatever product you're using. It'll talk some specific Bluetooth protocol to give your Wi-Fi password to that device. And that's kind of something that I don't really like. I don't like downloading a whole bunch of apps from sketchy places. Not that SmartWave is sketchy, but I didn't have to download a SmartWave specific app to pair these blinds. I could do it right through Home Assistant that I know and trust. And so Matter has established a well-known out-of-band protocol for scanning a QR code, transmitting your Wi-Fi or Thread password to the device, and getting it on the network so it can start the provisioning process over IPv6. So Matter really should take care of all of the steps in the process that have been painful before. So in case you're curious about some of the details of Matter on the wire, I've done some packet captures at a few different points in the network that we can take a look at. So here's an mDNS packet. It's IP version 6, of course. We expect that in Matter. We're using port 5353, which is standard for mDNS. So in this case, it's showing 4 Matter devices. So they are these IDs. 2 of them are almost the same, so 2 subfunctions at matter.tcp.local. And just like in normal mDNS, those are pointer records, which point to an SRV and a TXT for each one. So the SRV tells us the .local address of the device. So in this case, it decided it's going to be 3271 blah 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 .local on port 5540. And the text records have additional information. So here it's got SII and SAI, which are both some timeouts when the device is going to go to sleep. And T is 0 just tells it to use normal UDP. And then finally, we also resolve that .local to a full-on IPv6 address. In this case, it's on Thread, so the address is FDD0, blah, 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 blah. That's the IPv6 address of this device, which you can use to communicate with it. Now, the Matter traffic itself is actually encrypted, so it's on port 5540 there using IPv6. And all I see is just data, because it's entirely encrypted. In case you're curious about the header compression as well, here are some example frames from 6LoWPAN. So this particular frame is 113 bytes over the air, and that says over the wire, And that's very close to the 127 byte limit of IEEE 802.15.4. So in the IEEE 802.15.4 frame, we have a destination and a source address, and these are both 64-bit MAC addresses, which is very similar to Wi-Fi. So we like to fit this full IP header here, IPv6. And because IPv6 addresses are 16 bytes each, this header is 40 bytes. Out of our 127, that's kind of a lot. So here's some of the compression 6LoWPAN has done. So it has a context of FE80, so it's removing the first 64 bits because they're FE80 and that's a well-known link local subnet. And then it's filling in the remainder of the bits from the MAC addresses here. So in this case here, this 8CAB A44A, that's actually just computed from the MAC address here, 8EAB A44A. So we don't have to transmit it twice in the same packet. They've also compressed the hop limit down to just 2 bits here instead of a full byte, and also removed the IP UDP checksum and things like that just to save a bit of space. So in this 113 byte frame here, we have room for 89 bytes of this mesh link establishment protocol. And this capture was taken on my Raspberry Pi thread border router, so we can see the packets going across the thread border. So this particular packet came from one of the blinds, FTD0 B174. That's the unique local address prefix my thread network is using. And it's able to route that packet to my normal IPv6 network, my normal IPv6 addresses that my Home Assistant server is using. So now that I finally got it all set up, it's as simple as clicking on the device in Home Assistant and dragging it to whatever position I want. Now, in the time I've been doing home automation, I've noticed that some people seem to think of smart home technologies as just essentially a fancy remote. And of course I have that. I can control my blinds from my phone if I want to. But I also have the flexibility of building custom UI solutions like my Stream Deck. I've used this for a couple of years now to control the lights and stuff like that in my bedroom. Really helps when I'm doing filming. I can turn the different lights on, turns the fans off, things like that. But really, the real power of doing stuff like this is the automation aspect of it. I don't really have to tell the blinds what I want them to do unless I'm filming, because they do it automatically. So since everything runs through Home Assistant, I can take other sensors in my house. I have a sunlight sensor, for example, outdoor temperature sensor. I know the time of day and day of the year. I can calculate what angle the sun is at, and if the sunlight, the direct light, would come and shine in on my couch, or it could be blinding to me. And if light level is high enough, I can close the blinds automatically. I also have full control of what position they go to, so I can leave them open by about a foot to let my cat look out, because he likes that. And I can also have them open automatically. I like having my blinds open in the morning when I wake up so I can see the sunrise. So I usually have them automatically open at sundown so they're ready for the next morning. I'm also happy I got to work with SmartWave for this video. Their custom fit blinds do fit my windows very well. In the past I had some pre-made ones that came in fixed lengths, and there was about an inch gap on my blinds because they only came in 30 inch or 32 inch and my window is about 31 inch. So these are custom made to order down to the 1/8 of the inch and they fit perfectly. In the time I've had them set up, I have not had to charge them yet. The solar panels have done a great job. I even wrote an automation to move them up and down every minute for like an hour or two, and that didn't seem to drain the battery that much, so battery should last quite a while. I'm happy with that. I do still hate batteries, even though I have a whole bunch of battery-powered sensors in my house, so if you're building a house and have the option to run wiring, definitely run as much as you can. And finally, I am really happy to embrace the new Matter and Thread protocols and their IPv6-ness in my home automation setup. I'm really happy to move away from Zigbee and Z-Wave. And since I'm sure I'm going to get asked in the comments, here are a couple of networking side tips about making sure IPv6 works properly on your network. Of course, Matter relies on all the devices being able to communicate with each other over IPv6, including the Thread network. You don't need public global IPv6 connectivity for Matter to work. Everything just has to have a valid routable address. Remember, the Thread network is a separate subnet, so they have to be routable addresses. FE80 link locals aren't good enough. If you're using a commercial automation platform like Apple HomeKit or Google Home, those will both automatically set up a ULA, unique local subnet in IPv6 on the automation controller if you don't already have IPv6. I'm not entirely sure what Home Assistant does. I already have functioning IPv6, so I didn't have to set anything up with Home Assistant. It just used my existing global IPv6 connectivity. And again, your router doesn't have to route IPv6 in this case. Your network just has to support it on layer 2. If all of your IoT devices doing Matter are all in the same VLAN, that's perfectly fine. They'll be able to talk to each other directly. And similarly, you need support for mDNS or multicast DNS. And if your network isn't blocking anything on layer 2 and VLANs, this will pass through just fine as well. But if you're doing fancy network segmentation stuff, be aware that you're probably going to prevent Matter from working correctly. The Matter relies on these mDNS addresses to find the IPv6 addresses of devices regularly. It's not just a one-time thing during provisioning. It's routinely looking up their address and making sure it's correct. If you're using like high-end prosumer gear like Ubiquiti, I've already made a video about how bad their IPv6 support is up here, but that's probably not going to work too well for you. So IPv6 relies a lot more heavily on multicast layer 2 than IPv4 did. IPv4 was just kind of noisy. And a lot of networking gear doesn't properly handle v6 multicast or even multicast in general in v4. So if your switches and access points support IGMP snooping, which is IPv4, or MLD snooping in IPv6, enabling that, if it works properly, should be great. However, a lot of these devices don't properly handle multicast advertisements and things like that, and they'll just end up breaking all of multicast. So I have TP-Link Wi-Fi access points, for example. I can't use MLD or IGMP snooping because it doesn't work properly. Another quirk I've noticed is that thread border routers, the thread network creates its own ULA subnet and advertises that out as an IPv6 more specific route object. And these have been in the IPv6 standard the whole time, but they're not super widely deployed, and Linux actually will reject them by default. Every other operating system seems to accept these route objects correctly, but in Linux, it'll drop these more specific route objects and won't route packets properly to the thread network. Now, Home Assistant has some syscontrols you can enable to get around this. It's just a default problem. I mean, it has full support for these objects. It's just disabled by default. And if you're using like a commercial off-the-shelf thread border router, Apple TVs, for example, are really commonly used in this case. They have to be on the same VLAN as your Home Assistant device or it's just not going to work right. So don't segment them. Now, with all that said, I really hope you guys enjoyed this video, this overview of the Matter and Thread technologies and how great they are. I'm planning some follow-up videos on threads specifically. So I have a thread border router running in my network. It's behind me right now. And it was not an easy thing to set up. So you could use a commercial off-the-shelf one. Again, a whole bunch of home gear now includes it by default, like Apple TVs, Amazon routers. Not that I would want to run an Amazon router, but they include them. Google has some things like that, spyware. But I'm running one with a Nordic Semi dongle and a Raspberry Pi, and it was not easy to set up. All the software is open source, but it's still a pain. So let me know if you want to see other topics in home automation, in Thread and IPv6, that kind of stuff. I also have a Discord server link down below for that if you want to chat with me. I have a Ko-fi where you can give me tips if you appreciate my work. I really appreciate those. It's kind of like Patreon, but it's only a one-time thing, not a recurring subscription. So thank you for those. And as always, I'll see you guys on the next adventure.